Here we're going to integrate this different function. Okay, like let me treat the integral of sec² minus 2x from the basic law. Integral of a plus b gx is equals to what? Integral of a gx plus integral of b gx. A and b are functions. Okay, let's solve this key equation. That will be integral of 6x², that is from 1 to 2, minus integral of 2x, that is from 1 to 2. We're going to be having what? 6x cubed over 3 minus 2x² all over 2. This is the law of integration. Okay, x to the power n, integral of this is equals to x to the power n plus 1 all over n plus 1. That is a basic law of integration. If you don't know about this, I'll drop a video up here explaining all about this concept. I'll drop in the comment. Okay, from here you have a range that is from 1 to 2. We're going to substitute back. That will be what? 6 into 2 cube divided by 3, okay, minus 2 square divided by 2, all that minus, because we subtract from the lower bound, that is 6 into 1 cube, that is 6 on 3 minus 2 on 2. Okay, after computing this, okay, directly, you're going to be having 11 as the answer. The answer here is equals to 11. And move to the next one. Integral of cos x. You know that the key principle, okay, we have sin x, cos x, minus sin x, minus cos x. You need to know derivative very well. If you differentiate sin x, you are going to have cos x. If you differentiate cos x, you are going to have negative sin x, and so on and so forth. In the other side, if you integrate cos x, you are going to be having sin x. If you integrate sin x, you have this. If you integrate this, you have this. If you integrate this, you have this. Okay, integral derivative. Okay, the length of this one, that will be equal to what? Sin x with range from negative pi on 2 to pi on 2. Substitute back, that will be what? Sin pi on 2 minus negative sin pi on 2. I know someone asked me why am I using negative sin pi on 2 although it's sin negative pi on 2. In function, you know that sin theta is odd function. It's an odd function. Therefore, for an odd function like sin x, if you have sin of negative x, that will be equal to negative sin x. But cos is an even function here. In case it was cos, if you have cos of negative x, that will be equal to cos x. Okay, take this into consideration, or this is a key concept. Okay, therefore our answer here will be what? Sin pi on 2 is equals to 1. Therefore here we are going to be having 1 minus 1, that is equals to 2. And this is the exact answer here. The next one, we have integral of sec²x. Easy. The integral of sec²x is what? Tan x plus k. The question you're going to ask me, why is it like this? You need to know about derivative very well, because if you differentiate tan x, you are going to be having sec²x. Automatically, if you integrate sec x, you are going to have sec²x, you are going to have tan x. That is the answer. Easy. If you want to understand better just ask me. I'll drop a video in the comment up here, or in the comment I'll ping it, solving integral of sec²x in another video. I just skip it because here you are gaining time. Integral of sec² plus sin x plus 2gx. That is very easy. That will be equal to what? Integral of sin x gx plus integral of 2gx. And our answer will be what? If you integrate sin x, you are going to have what? From our principle, you are going to have negative cos x gx. Okay, negative cos x, sorry. You have a plus k here. Okay, since it's another one, just keep the k aside. Plus, if you integrate 2gx, you are going to have what? 2x plus a constant k. And the key, oh, sorry, is here. And the answer is this one. And the answer is here. Negative cos x plus 2x. They forget to put it plus here. That is plus 2x plus k. That is the answer. Because sometimes they make error. If you see like this, you should just take this because that's the most correct answer. This one doesn't even resemble the answer. This is the one. But while punching, they put but a dot here. Although it was supposed to be a plus. Take that into consideration. We have integral from 0 to 2 of x cubed plus x squared. We use the same principle. That is integral of x cubed plus integral of x squared, gx and gx with limit from 0 to 2. Okay, our answer will be x cubed. Okay, x to the power 4 over 4 plus x cubed on 3. That will be equals to, with limit 0 to 2, that will be 2 to the power 4 all over 4 plus 2 cube on 3 minus 0, because 0 on 4 is 0. That is 2 to the power 4 divided by 4. 2 to the power 4 is equals to 16 divided by 4, that is 4, plus 2 cube divided by 3, that is 6.66, that is 20 on 3, that is 600. Okay, 600 is the answer. Normally you are not going to use a calculator in doing this. Okay, let's not use a calculator and do it ourselves. That will be equals to what? 16 on 4 plus 2 cube, that is 8 on 3. And you're going to add this and come out with this exact answer. You have this other integral that is 2x plus 1 all that to the power 3. Okay, looking at this integral is somehow easy and tricky. If you differentiate 2x plus 1, you are going to have what? 2. Okay, integrating, therefore our answer will be half times, you have this, that is u like u, that is 2x plus 1 all that to the power 3 plus 1, that is 4 all over 4. And the answer is what? 2 to the power 4, that is the answer, all over 8. Okay, let's come back. I know some guys are not understanding. We take our u equals to what? 2x plus 1. gu is equals to 2. Because it needs to be used to integration so as to solve easily this question and gain in time. Since we are running against time, it's equals to gu all over 2. Okay, therefore our integral will be integral of u cube. Okay, u cube gu all over 2, because we substitute gx. That will be equals to what? U to the power 4 all over 4 times this 2. That is u to the power 8. And our u is equals to what? 2x plus 1. That is 2x plus 1 to the power 4 and 8. That is why we choose this as the answer. But someone that already know what is this, we just have to take and differentiate this, since it's of first degree. If there was a square here, that cannot be. As long as it's of degree 1, you can apply this formula and you differentiate what is inside here. That is, if it was 3, that would be 1/3 and so on. Okay, since it's that, you differentiate and you have half and you have 2. Okay, you bring the 2 bit down and you substitute back what is inside here, substitute back and increment this all over 3 plus 1, applying the basic law of integration. Okay, hence we come to the end of this amazing video. If you found it interesting, push it up. Goodbye.